We present Toon3D, seeing cartoons from new perspectives. Here we reconstruct the restaurant from Bob's Burgers. Our method takes a few hand-drawn images and lifts them to 3D. Here we show an example set of input images used in our method. In order to lift these images to 3D, the images need to be drawn consistently. It's difficult for humans to tell, but structure from motion libraries like ColMap will fail. Even if we hand-label correspondences without any outliers, ColMap still fails. We can try bundle adjustment with hand-labeled correspondences, but the result is very bad. Here we solve for cameras and sparse points and visualize the result by back-projecting depth maps from the cameras. Our method achieves much better results. We can recover camera poses, warped perspective images, and a densely aligned point cloud. Notice how consistent the structure is. Now we visualize the methods with Gaussian splatting. We compare bundle adjustment with manual correspondences versus our method. The cameras are following the same path, with the nearest camera shown in the corners. The bundle adjustment method on the left has a messy structure because the cameras are inaccurate and Gaussian splatting overfits to the input views. Our result is much better at novel view synthesis and obtains a more consistent structure. We compare against a variety of methods including duster and duster with our 3D correspondence loss. Notice how only our method provides a consistent and reasonable solution. We provide quantitative numbers in the main paper. Here is our labeler in action. We can add points, check the depth maps, and remove objects. The labeler is a website for easy use and no installation. We visualize images side by side and it's easy to switch images with arrow keys or clicking the image icons at the top. We labeled 12 cartoon scenes to create a dataset with 79 images total. The labeler in our dataset will be released. Our method recovers structure by aligning labeled correspondences guided by our camera alignment and deformation alignment losses. Here is a visual where we show various parts of the optimization, starting from 3D points and a sparse mesh and ending with refined Gaussians. Lastly, we initialize Gaussians with our point cloud and train Gaussian splatting with our warped images. Here are some results of our Gaussian splatting visualizations, with the point cloud shown on the left. We run our full Toon3D method on 12 cartoon scenes, shown here. Also, please see the paper for ablations that describe the effects of our losses. We can visualize the warps. In the middle, blur indicates where it warped. Here we can see how the images warp during optimization. The warps are subtle but effective at making the drawings 3D consistent. An application of our Toon3D labeler and method is sparse view reconstruction. Imagine we have the Airbnb listing shown here, with a few photos per room. To reconstruct this room, we can try running ColMap and Gaussian splatting with Nerf Studio. However, only 2 out of 5 images are registered and the results look quite bad. Using our sparse labels, we can make ColMap work for 5 out of 5 images, but the sparse initialization is difficult for Gaussian splatting to densify. Using our labels and our method, we can initialize Gaussian splatting with a densely aligned point cloud and train to add details. Here is another room from the Airbnb listing and our reconstruction. We can also reconstruct paintings. Using the predicted depth of each image, we align and warp point clouds and perform Gaussian refinement. This result is from 8 paintings of the Trevi Fountain. Thank you for watching.